Today's lesson is going to be on Algebra 2, Unit 1 from Khan Academy. This is going over quiz number 1 and some of the topics that are on quiz number 1 that are related to polynomial arithmetic. So we're going to talk about things like how to subtract and add polynomials and the degree of polynomials. So here's our first question. I'm going to share my screen here and we'll look at the first question together. It says subtract 9a squared minus 6a plus 5 from 10a squared plus 3a plus 25. So we're going to start with the 10a squared plus 3a plus 25. And then we're going to subtract this from that. So we're going to write it like, let me scoot this over actually. I was going to write it in columns, but I think it might be easier if we write it like this. So we're going to say minus all in parentheses 9a squared minus 6a plus 5. Now, when we subtract all of this, that minus sign is going to distribute to all three terms here. So now this becomes 10a squared plus 3a plus 25 minus 9a squared plus 6a minus 5. Now we're just going to combine like terms. 10a squared minus 9a squared is a squared. And I like to cross these off as I go. 3a plus 6a is 9a. Cross those out. And 25 minus 5 is 20. And so that's our final answer for that one. I'm just going to type it into Khan Academy, and we'll make sure we got the right answer here. Okay. The next question is a graphing question. So here's our next question. It says, what interval, let me copy it here. So it gives us this function. It says, what interval does f have a positive average rate of change on? So this is our function f of x equals x squared plus 10. F of x is pretty much just like saying y equals. So let's go to Desmos and we'll take a look at the graph of this x squared plus 10. So I'm just going to type f of x equals x squared plus 10. And that's our graph right there. And you can zoom out if you need to look at your graph in different ways. You can zoom in and out if you need to. It'll change the scale of the graph. So now it says, over which interval does f have a positive average rate of change? So now we want to look at these different intervals. These are all options of if is the slope between these two x values, is it positive? That's what we're trying to find. So if we find x is -3, that's here, where x is -3, trying to get right on there, -3. And then when x is 1, that's here. So if we drew a line that was between those 2 points, that has a negative slope. That line's going down. So it's not A. If we check B, -1, let me zoom in so we can actually look at the right scale factor here. So each one of these spaces is now 1 because I zoomed in. So now -1 is right here. And going to 2 is here. That looks like it would be positive. It's going from 1 to 2. It's increasing. So we'll put B as our answer for now, but let's check the rest of these just to make sure. -3, 3. Just going to scoot this up. These are still going by ones here. -3. And then if we go to +3, that would be here. That would just be a flat line, and that would be a 0 slope. So that's not positive. and then negative 4, 1, negative 4, 2, 2x equals 1, I should say. Let me zoom out just a little bit more. So here's negative 4 and negative, if we go to negative 1, that's down to here. And so that would make a line from here down to here. And that would be a negative slope. So it's going down that way. So we were correct. B is the right answer for the positive slope. So negative 1, and then here's 2, and that's a positive slope going up, and to the right is a positive slope. Okay, so this one is B. All right, we'll check the next one. It says, which polynomial is in standard form? So standard form has to do with organizing everything in, organizing all of our terms from the greatest degree to the lowest degree, all the way to the constant. And if we skip some, I'll show you here. So standard form is an example of that is like B. So our squared term is the biggest term out of all of them, has the highest exponent. The not squared term, just the to the power of 1 term, is next, and then the constant is the last one. For C, we have the highest term is t to the 1, and then our constant. So that one's standard form. And then A also is standard form. So it's going t to the 4th is the highest exponent, but there's no other exponents after. So there's 0t to the 3rd, 0t squared, and 0t. But we don't write those in there. We just write t to the 4th. And then there's a negative 1 for the constant, or minus 1. So t to the 4th minus 1. So all three of these are written in standard form. All right, so we've got a couple more of these. Some of these are organized where we have to add these equations. And I think a lot of people are really good with this already. So if we add these together, this says, what's E plus F? So it's a lot easier to add polynomials because you don't have to worry so much about the parentheses like we did on the first problem. Let's go back to the first problem. The first problem, we had this minus here, and that minus had to go to all three terms. But if we write this out with a plus, the plus doesn't really change anything. So if we write it like 6c squared minus 2c minus 1, and then if we plus all of what f is, that's negative 4c squared plus 7c plus 5. We don't really have to do this because that plus doesn't change any of the signs that are next to the number. So we can get rid of the parentheses when there's a plus. So now we just combine the like terms. So 6c squared minus 4c squared is 2c squared. We just cross those out. Negative 2c plus 7c is 5c. We cross those out. Negative 1 plus 5 is 4. So that's our final answer for that one. That one's not too bad. I think most people are very comfortable with combining like terms. I think that minus 1 from the beginning, though, that one's a little bit trickier with the parentheses. All right, we're going to do one more average rate of change problem. This one gives us the intervals of x as an inequality. So if we go back up here to this question, it said, what interval does f have a positive change? That was this question here. And so we can write intervals like this. When there's a bracket, it doesn't mean that's the point. It means that's x and that is also x. So we checked when x was negative 1, just kind of going back here to the last problem or a couple problems previous. When x was negative 1, and then when x was 2. And then we were able to find out that there was a positive slope between those. So we can also write this interval as x is between -1 and 2. So that's the same thing as this. Those are equal statements. So this next problem tells us it doesn't say f of x, it uses g, and it uses g of t. So basically, we're just saying that t is the same thing as x. So um, we're saying that g of t is like y, and that t is the same thing as x. And if we type this into our calculators on Desmos, it will show us a new graph. And you can use f of x too if you wanted to. That's fine, as long as you keep everything consistent. But I'm just going to use y instead of f of x this time. You get the same basic result. So here's our function. And as you could see, we didn't get to the function right away. I had to kind of move around and scroll out with my mouse. So now let me zoom out from here so we can see the question at the same time. It says, what's the average rate of change over the interval -4 to 5? So we're going to find where x is -4. These are going up by twos right now. There we go. Now our grid's showing us 1 for every space. So we're going to go to -4 on the x. That's right there. And I'm just going to type that point in actually, just so you can get a better visualization. If maybe I didn't explain it quite as good last time without putting the dot on the graph. I think it's easier to see if we write it like this. So there's our first point. When x is -4, y is -20. And then when x is 5, that is right here. So when x is 5, y is -11. I'm just going to put that also. So now it wants to know, what's the average rate of change between that? Well, the average rate of change is the slope. So I'm going to copy this. I'm just going to copy this entire graph to our whiteboard. And you don't have to do this when you're solving these. You can definitely just write them on paper and have your graph open. That's fine. If you have your graph open and the problem, that's perfectly fine. But this should be some review from Algebra 1. So this says, what's the average rate of change between those two? And the average rate of change is the same thing as slope. Our slope formula is y2 minus y1 over x2 minus x1. So let's call the blue one point number 1, the blue point. So that's x1, y1. And we'll call the green point point number 2. That's x2, y2. So y2 is -11. Kind of a little difficult to see the negatives there, so just make sure you have the negatives where they need to go. And you can probably just check there too if you write them down that way. But you don't have to write these down if you don't want to. So -11 minus -20, and then x2 is 5 minus x1 is -4. So we have some double negatives going on here, and we just have to simplify those correctly. So -11 plus 20 over 5 plus 4. So m equals -11 plus 20 is 9, and 5 plus 4 is also 9. So our slope, or our average rate of change, is just equal to 1. Okay, so that's everything from quiz number 1, unit 1 for Algebra 2.